Oh, thank you. You haven't heard the talk yet. So, hello, I'm David Asboth, and we are going to be putting Python in our Python so we can code while we code. Hands up if you understand the reference. Oh, quite a lot of you, good. I looked this up, and now you have to know too, the original show, which I won't name to help our captioning team, it aired over 25 years ago, so you have to know that as well now. I know, I laughed when I heard that as well. Okay, so imagine you are all Python developers. Well, you probably all are Python developers. So you have been tasked to implement the amazing Code Checker 2000, right? This is an amazing website where you can type in any Python code that you want into a text box. And it goes away, gets checked, and then gets verified with some kind of success message, right? How would you do this? This is partly rhetorical because I'm going to tell you. Okay, but first of all, we need to understand what exactly I mean by putting code in your code. Sounds funny as a meme, but we also have to be sure we're talking about the right thing. So first of all, just sort of nod your head or shake your head. Do we think this is Python code? Yes, some nods, good. It's not a trick question. We've all run this Python code, right? It's perfectly valid. Good. All right. So what about this? Can actually see anyone? Okay. So yeah, it's a comment, someone said. Okay, a few shakes of head. Okay, this is a little bit more philosophical, right? Because this is technically a Python program. If you run it, it runs. There's no output, but it runs. It's just a string. We don't do anything with the string. We don't explicitly print it. It doesn't go anywhere. We don't even save it into a variable. But it technically is a Python program. Now, with our human eyeballs, we can see that this string happens to contain valid Python. But in terms of the Python interpreter, it's just a string. It's just characters. It could be anything, right? So the Python interpreter doesn't see this as Python code, it just sees this as any old string. And this is what I mean about putting Python in our Python, because there is extra code in our program which doesn't actually get run as Python code. But can we somehow access the contents of this string and run it as a program? Well, we can, otherwise this talk wouldn't, exist. Why would I be here if we couldn't do it? Turns out you can just wrap this whole thing in a call to the built-in exec function. And what that does is it takes a few things, strings and other things, which we'll talk about, and gives you, the output. It actually runs the Python code. Hopefully some alarm bells are going off at that point, and we will return to those. But when it comes to the amazing Code Checker 2000, we could just use this Python functionality, take whatever the person has put into that text box, they've attempted Python code, run it through exec, just some very naive, put it in a try except block or something, and then print a success message if it runs. If it triggers some kind of error, syntax error, or anything else, we can print a failure message, right? Now, we would obviously do a lot more things, but at a very simple level, we would use exec to take the user input and just run it on our own, on the server. Now, when I say we can run Python code, do I really mean we can run any Python code that comes our way? Now, if you read the documentation, there are a few edge cases that you can't put in an exec block, but generally speaking, we can actually just put whatever we want in it in terms of Python code. So could we use existing variables that are created outside of exec, passed in as part of the string that represents Python code that goes to exec? Yes, it's fine, totally valid. Could we do it the other way around, more interesting? Can we create a new variable inside the string that gets passed to exec and then reference that variable outside the block? Yeah, we can do that too. Now there's a specific reason that that works here. We'll come back to that in a bit. But because we can create new variables, and variables are just objects, and everything in Python is an object, stands to reason, could we then also create new functions? Right? Could we define a function for the first time in a string, pass it to exec, and then use that function afterwards? Yeah, we can do that too. Fine. Just objects. So we can actually create anything. Could we create classes? Yeah, we can create classes. And this actually becomes quite useful. We'll return to this specific use case and when we talk about exec in the wild in a few minutes. But yeah, it's fine to define a class for the first time in a string, pass it to exec, and then get the output and use that class for the first time, instantiate it, print it. Absolutely fine. Now, I hope I'm not the only one who sees the fact that we can pass in Python code to exec and immediately thinks, can we do this? Can we pass exec into exec and then run it? What do we think? Yeah, of course we can do that. Python is dynamic, you can do whatever you want. Yeah, you can pass exec into exec and run it, absolutely no problem. You can keep going. Keep passing as many exec calls as you can, and you start getting, it's really difficult to type any more than this because you have to think about all the different types of quotes that have to exist. This is the maximum I could figure out easily. But yeah, you can keep going. You can nest exec inside exec inside exec. Execception, if you will. Again, that reference is now 15 years old. But yes, that runs. Absolutely fine. Okay, so that's pretty cool. But how does it work? So what can we do? I mean, so far we've just seen that we can pass in a string that happens to contain valid Python, and exec will run it for us, give us the output, do whatever it is. It's as if that code had been Python code in the first place and not a string. So let's have a look. We'll have a look at the function signature from the documentation. The first thing we see, which is the thing that we've been using, now you can see everything has defaults, which is why we could just pass a string and no other options, not bother with the other options. So first thing we need to pass in is a source. Now, so far we've just been using strings. It's a typical use case is to pass a string, build that up dynamically, do whatever you want outside of the exec block, build up a string that represents Python code, and then pass it to exec. But it could also be a code object. Now, I come from a data background, so I am now in that 51% of people who mostly use Python for data science. So before researching this talk, I hadn't actually encountered code objects. Does anybody use them in the wild? Yeah, a few people. Okay, that's pretty cool. All right, this is another cool thing about Python, is you can represent a chunk of executable code as a special type called code, right? So it's a specific object that has been created from Python source, compiled, turned into a code object. So we can create a code object using the built-in compile function. Does anybody use this a lot in their work? Okay, a few people use this. You can talk to me afterwards. I'd be very interested to hear about more use cases. So this requires a few options. We can pass in some source code, which could be a string most of the time. As it says, it could be a normal string, byte string, or an AST object. We won't talk about that too much. It also needs a file name, which I think mostly for error messages, so you know where that sort of dynamically generated code has come from. I like the fact that there is a common value given to us in the Python documentation, so like what you should use for that value, and then there's some other options you can set, but essentially it takes code that is in a string, pass it to compile, you get out some code object, which we've seen should be a code object. So that's the return value from the compile function. And then we're just going to check the type, and then we can pass it to exec just like we could pass a string. So it's just a couple of extra steps in that process we've already seen. But yeah, this works just the same. And we see that it's a specific code type, but it still just executes the code as if it was already in our application. Okay, so there's two reactions to this. One is that is really cool, right? That we can just build up a string with Python code and run it at runtime, sort of YOLO style. But sort of alarm bells should be going off, right? Especially if we have a text box somewhere where somebody can type in arbitrary Python and send it to our application and run it. That's pretty worrying. And I don't know if there's that many places in the Python documentation that has a big pink warning about its own functionality. But it's like, this, you know this executes arbitrary code, right? Like people could send you whatever, and it could be a security nightmare. And it is, right? Absolutely. Funny thing is, I can't remember which AI it was. I thought I'll just try, see what it says. Give me an example of a vulnerability, like importing OS and then running something like RMRF or something. And it was like, no, I won't do that. I won't tell you how to do it. Okay, so it stopped me hacking into some system or something. But yeah, just imagine there is some malicious code there, right? The user like imports the OS module and then goes and deletes your file system or something. If you're not careful and you just run this on your web server willy-nilly, you've lost your web server, right? So you really have to be careful. So how could we prevent this, apart from shutting down the amazing Code Checker 2000, which is also a valid security option? What could we do? Well, let's have a look at how we could change the call to exec to help us. Exec has some other options that we can set at the time of running this dynamically generated Python. And there's some options called globals and locals, which let us do a couple of things. One of the things you can do is create like your own custom namespace in the place where you are running this dynamic code, and that's where you want to store your new variables so it doesn't litter the rest of the scope. Or we could use it to pass in like a fake version of all the globals from your Python program and limit what the code inside the exec block has access to. Okay? So the default is, as you can see from the Python documentation, is that if you omit all these optional parts, which is what we did in all our previous programs, then the code is just executed in the current scope. So if you're running it in the global scope, that's why all the newly created variables are created in the global scope and therefore are used in the rest of the code okay, which is also why it also has access to stuff that you previously saved in the global scope, right? But with these extra parameters, you can kind of control that. So for example, as a sort of very blunt instrument, we could say, when we allow someone to run their arbitrary Python code on our system, we will overwrite this globals dictionary rather than give exec access to everything in the global scope. We will just give it a subset. So we'll say, okay, yes, there are some built-ins, but you can only have a print function. And when the user calls the print function inside this dynamic code, then just call the regular print function, but nothing else. So when the code is executed and someone's trying to use a built-in method that isn't in our custom dictionary that we've set up here, we'll get an error. That even works for importing. Like even the import command doesn't register because we've restricted the built-ins to just whatever we control. Now, it's a bit of a blunt instrument, and you probably have to do a lot of thinking about what to allow, what not to allow. It's probably not the best way to do it. If you are building a code-checking website where users can execute, or the server can execute users' arbitrary Python, you should probably sandbox it. This was PowerPoint's idea of stock image about sandboxing, so I thought I'd keep the camel. It's pretty cool. But just sandbox it, right? That's probably what happens in all these code-checking code platforms. The code that you run is executed in some containerized virtual machine, something environment where you can't really do any damage. Worst that you can do is delete the files, nothing happens on the web server, right? This is how you can also get ChatGPT to crash or whatever by making it run RMRF or something. It doesn't actually break the whole website, just breaks whatever particular little environment was spun up just for you. So yeah, if you're going to allow malicious code, at least sandbox it in some way. So that's really the preferred way. But you can also change some of the options in exec. Okay. Now, I've just spent a few seconds telling you this is a really bad idea to execute dynamically generated code, especially that comes from somewhere else. So let's talk about some actual use cases, right? Some places where exec can be maybe the right solution, or at least an appropriate one. So let's look at exec in the wild. So one of the places that I found it is actually in Python itself. So in the implementation for named tuples, which have dynamically generated attributes and so forth, there is actually a call to eval. The eval is like exec, a bit more restricted. It has to return an expression, so you can't just create a variable and nothing else. It won't work with eval. But think of it as exec, basically. And so this is what it does. It sort of builds up all this stuff dynamically and then executes it. Now it's very controlled, right? It's not like the user can type in any code and then insert malicious code into the Python source code or anything. But it makes sense to create a dynamic object with dynamic attributes using this dynamic code generation with eval. So even Python itself uses it in some places. Okay, the other way you might want to use this, now no ORMs actually just use exec to generate, equivalent classes, but, it is a place where we could conceivably use this idea of especially dynamically created classes at runtime. So what we're trying to do, in case you haven't used a lot of ORMs, object relational mappers, the idea is you have some data, right, on cartoon characters, and we want to represent them as Python objects, right? Now, we could manually create a data class and add the right fields based on whatever is in the database, and then we could create an object of that type and print it, we could do that manually, or we could write some clever code that inspects the data. So I'll show you an example in a second. We'll just look at the headers in a CSV file. And whatever we find, they are going to be dynamically all the attributes in our data class. So the same code run on different data sets will produce different data classes, which is pretty cool. So we're going to read in a CSV. I won't talk about it line by line, but you see that there is a sort of boilerplate section where we import data class, create a class, we're always going to call it row, but the actual attributes that go inside it will come from the CSV file. So if we pass different CSV files to this code, it will create different data class objects dynamically at runtime. Now, I've been lazy, I haven't even bothered with typing, so everything is just going to be a string. Now you could do a lot of extra checking, if this is a series of numbers, change it to int and so forth. But for our most simple example, we'll just assume everything is a string. And if you've worked with real data, everything probably is going to be a string. And then at the bottom, we're just going to take all the rows from the CSV and convert them to this dynamic row object, which means that this same code run on different source files will produce different results. So for our cartoon characters, it's going to take the name and the species columns, and make those the attributes of the data class. But if we run it on a completely different file that has name, number, and color, then we are going to create a completely different data class, still called row, but it's going to have different attributes, name, number, color, from the data. Now, as we'll talk about in a second, this isn't exactly how ORMs are going to do it, but if we're going to make a very basic equivalent, using exec to dynamically create those classes is an option. Now, the other one that is fairly popular is domain-specific languages, DSLs, so like custom scripting languages for your applications, right? Now, this is a very contrived example, but let's say we want a little application that supports commands like at the bottom, add 1 and 3, subtract 1 and 3, multiply 4 and 3, right? Now, yes, we could just solve this with an if statement, and so maybe a clever case statement or something, but we could also convert it to an equivalent Python expression. So the add 1, 2, 3 syntax could be converted into the Python 1 plus 3, the subtract 1 minus 3, and so forth, right? And then we could execute that dynamic Python expression, so essentially converting the scripting language directly to Python. And when it comes to like a big script in this custom language, we could just do it sort of line by line, to convert it into a small Python program, and just run it at runtime using exec. Now again, this is probably not how you would implement a DSL. There are better tools for it, but again, exec would let us do it. This is exactly the right kind of thing where exec could be used. All right, now the question, should you use exec for these cases? Now, when it comes to like actually having a text box where you need to just run somebody else's code, it's probably going to be your best approach. If anybody has done something different there, I'd love to hear about it. But even then, there's all these infrastructure questions, right, about making sure people don't inject malicious code into your web server. When it comes to like ORMs and DSLs, there are more mature tools out there. There are better ways of doing it. So for mapping data to custom classes at runtime, you could use the types module, or you could use data class's own make data class. So there are ways to create dynamic types, right, at runtime without resorting to a string that represents Python code and running that. And then for DSLs, there's a bunch of dedicated tools like abstract syntax trees and so on, where you can do it properly, and again, not just build up a string that represents Python code. There will always be better methods. So in conclusion, should you use exec to dynamically create and run Python code? Probably not. It's really cool. I'm fascinated by this, code that generates more code, but it's probably not the right approach for most of the things you want to do. Reach for better things, and I think Ian Malcolm would approve from Jurassic Park. Just because you can doesn't mean you should. All right, so I'm around on the internet. You can find me at various places. So I train people in Python and data science. That's my day job. I also co-host a podcast called Half Stack Data Science, which you can check out. Recently, we talked to Simon Willison about AI and coding, and we have some cool guests on there that you can listen to. It's free. You can go on and listen to it wherever you listen. And I also wrote a book called The Well-Grounded Data Analyst, which is a collection of real-world, true-to-life data science projects for you to attempt. All the example solutions in there are in Python, actually. And if that sounds interesting, if you're into the data thing and you'd like some more practice in your data skills, come see me before the end of the day. I have 2 copies in my bag that I'd love to just give away to people if you're interested in that kind of thing. So just come and see me. I'm happy to give you a copy. I've left some further reading in. I'll make the slides available and so forth if you are interested in dynamic code generation. But otherwise, thank you very much. Okay, so I think we have time for maybe 1 or 2 questions. I can't actually see anyone.
Do you have any recommendations for resources on sandboxing further access from exec if you do have to run other people's unvetted code?
Not personally. It's not a question that I've had to wrangle with from the infrastructure side. I mean, we're talking probably infrastructure more than anything. So I would look at things like Codecademy and these websites that do it, and then presumably some of them have engineering blogs where they would talk about that thing, because that's a perfect use case. Somewhere it's like a Python tutor type thing. So I'm sure some of them will have some resources there. Okay. All right. Well, thanks everyone. Again, if you'd like a free book, you can come and see me. Otherwise, thank you very much.